Hey guys, welcome to my YouTube channel. So on this video I'll be doing casing. So I'm not doing like the intro, I'm just focusing on this question since I have to help someone, but later on I'll try to make like an intro and everything which is based on chemical equilibrium. So let's start. The statement says on question 15, initially we have 60,8 gram pure of carbon dioxide which is reacted with carbon in a sealed container of volume 3 dm3. Now the reaction reaches equilibrium at temperature T. Now they've given us a balanced equation. The first question says define the chemical equilibrium. I'm not interested in that. I'm interested in this question which has 7 marks, which says at equilibrium it is found out that concentration of carbon dioxide is 0,054 mole per dm3. Now it says calculate the Kc or equilibrium constant. For us to calculate the Kc, this is how we start. Okay, so the first thing that you must know is that Kc is equal to the concentration of product over the concentration of our reactants. Now how do we get a concentration of these two? Now the first thing is that you must let me just copy the balanced equation over here, which is C in S plus CO carbon dioxide G, now reversible CO in G. Now the first thing you should do is to write what is known as the equilibrium table, or I call it the Rice table. So it's Rice table. Now this stands for the ratio of the molecule. This is the initial number of mole. There is the change in number of mole. This is number of mole at equilibrium, and this is concentration. Now we should note that on our balanced equation we have 4 different phases, which will be either a solid phase, gaseous phase, or liquid phase, or aqueous phase. Now when we do this chemical equilibrium table, the only ones that we include are the ones which are either in gaseous surface or aqueous phase. Now if you look at this balanced equation, we only have gaseous and solid. Now solid does not apply because they do not change in the reaction. Therefore I'm going to include only these two just because they are in gaseous phase. Now we have carbon dioxide and carbon monoxide. Now let me just throw my table over here. I'm just doing this quick video because I wanted to help someone, but I will do the full video on chemical equilibrium. Yeah, now let's start. The first thing that we should note is that our goal, or our main goal, is to have concentration of these two so that we can calculate the Kc as requested. Now the first thing here is the ratio of the molecule. As you can see here on the balanced equation, this has 2 ratio and it's 1. It means that it's 1:2. Now at initial, this is the way we put our number of mole. We have to put a number of mole which are at initial for carbon monoxide and carbon dioxide, but since this one is a product, it means that on our product every time initially we have 0, but what do we have initially at carbon dioxide? We don't know. Now let's go back to our statement. So we're gonna have to write down our data that we're gonna get from the statement. It says initially we have what? We have 60,8 g of CO2, of carbon dioxide. Now if we go ahead and we read which is reacted with carbon in a sealed container of volume 3dm3. Now we have the volume which is equals to 3dm3. Now let's go ahead. It says the temperature reaches equilibrium. Now we jump over there, we come here. It says at equilibrium it is found out that the concentration of carbon dioxide is 0,054 mole per dm3. Now this is our concentration for our carbon dioxide at equilibrium. Now let's go and look at what we don't have here on the table. Now we are looking for the number of mole of this at initial, and they told us that at initial we had 60.8 gram of what, of carbon dioxide at initial. Now let's look for number of mole of this one. Number of mole, since we have mass, we will use this one, which is like that, mass over molar mass. Now if we look at our mass, they said it's 60.8 over what, molar mass. Since it's CO2, it means that we have 3 molecules. Now it is 12 plus 2 of what, of oxygen, plus 16 plus 16. Now this will be 32 plus 12, that will be 44. Now let's look for our number of mole. Let me get my calculator over there. 60.8 over 44, that will be 1,38. It means that our number of mole is 1,38. Now let's put our number of mole where it is needed. Now we're gonna put 1,38. Now we have to fill all this table. What also did they give us? They said at equilibrium, which is here, at equilibrium, carbon dioxide has concentration of that one. Now the other thing that you should note is that this concentration is a concentration of number of mole of this at equilibrium. Now they've given us 0,054 at equilibrium. Now we have to fill this one. How do we fill this one? So since you know that concentration, it is equal to number of mole over volume. Now they've given us 0,054 of what, of concentration of carbon dioxide. Now we don't have number of mole, but they gave us what, volume. It means that we're going to multiply 3 by 0,054. Number of mole will be equal to, let me just, 0,054 times 3, and it is equal to 0,162. Now this is our number of mole over here, 0,162. Now how do we get this? You will never be able to achieve or get number of mole or change in number of mole by reading the statement, but you can get it by doing what, by subtracting this and this, because this is it's more like in excess is what is left. So this is the change that we get after solving for these two. Now how do we get this one? We say this minus this gives us this. Therefore let me just do that by calculator. 1,38 minus 0,162, and it gives us 1,22 or 1,218. Now what you should note that when we talk about the change, it's where we also use our ratio. Now since you know that the ratio over here is 1, it means this is 1, and the ratio over here is 2, it means this is 2. You should note that every time whatever this, it is equal to this, but since the ratio says this is 2 and this is 1, it means that this is the half of this. How do we get this? We multiply this by 2. Now let me just do that on a calculator, times 2, and it is equal to 2,436. 2,436. Now since this is 0, it means that there's no change. It is going to be 2,436. Now let's get our concentration over here, which is the product carbon monoxide. Now concentration, as you know, this formula, It means that we just go over here and say concentration equals to number of mole, which is 2,436 over what? Over volume, which is 3 dm3. Now let me just do that. Divide by 3, it gives us 0,812. That is our number of our concentration, 0,816. Now I'm sorry, 0,812. Now we go back to our first mission, which was to get our Kc. Now as you know, the Kc over here, it says what? It says concentration of product over concentration of reactant, which means it's the concentration of product over concentration of reactants. Now we write it like this. These brackets show that it is concentration 812, and we have 0,054. Now you should note that whatever ratio we get on the molecule, we say that number of ratio, we put it as to the power of that molecule. Since this is our product, which is carbon monoxide, and it has a ratio of 2, we say to the power what? To the power 2. As you can see here, it said CO2 like this. This doesn't mean we have 2 square. This just means that we have 2 molecules of what? Of oxygen. Now let's get our Kc. Our Kc, let me just say this, put that on a calculator. Okay, let me just, it says 0,812 squared over what? 0,054, and it is equal to 12,21. You should note that Kc does not have SI unit. So let me just repeat. So the first thing, or the question was saying, we must calculate the Kc of the reaction, which is this one. Now how do we get the Kc of this reaction? So for us to get Kc, we must have concentration of product over concentration of what? Of reactants. You should note that when we use this table, we only use the molecules which are under two phase, which is gaseous phase or aqueous phase. We don't use solid phase or what? Or liquid phase. That's why I didn't include our carbon on the table. Now after that, we go on our information and use it to get whatever we want. Now here what they need is the number of mole of this molecule at initial, number of mole at this at equilibrium. Once they say that we have concentration of a certain molecule at equilibrium, it means our concentration is here. But let's just say if they said it had initially it had concentration of this, it means that what we were going to do is to write that concentration down and manipulate it to get what? To get a number of mole of it. Let's just say C equals to NV. They gave us C. It means that we're just going to multiply get our number of mole and use it over here. When they say concentration, you don't put concentration here. You have to calculate for number of mole. So yeah, if you have any question, just leave a comment. I'm using a document which is grade 12 last push. Yeah,